In this example, we are going to be considering a graph and its MST. So this is the scenario. We want to pick an edge, modify it, then its cost changes. Then we want to see whether this modified edge with new cost is part of the MST or not, without actually reconstructing the MST from scratch. So if you want to think about this question, please pause the video and read it, think about it, and let's get back. So let's look at the first question. You have an edge that is not part of the MST, and after modification, its weight is greater than its former weight. So I think this is very clear. After modification, its weight or its cost even became bigger. So we do nothing, right? We do nothing. This is not part of the MST. Do nothing. So let's look at the B part. We have an edge that is not part of the MST. So if edge is not part of the MST and its new weight is less than its former weight, what do we do? So for this one, if its new weight is less than its former weight, it's possible that it could make it to the MSTs because it's now cheaper. Who knows by what? So what we're going to do is we look at all the edges in the MST, and in particular we look at the edge in the MST with the maximum cost, and we compare it to W hat, which is the new cost for E. If W hat is less than this edge, if W hat is less than that maximum in the MST, then what we do is we can remove that maximum. We remove that MST's maximum and replace it with this new edge. If doing this does not disconnect the graph and does not form cycle. So that's the condition you must always have in mind. So I don't know whether there's any need to write this. It's pretty clear. If the maximum edge of the MSC, if the cost of the maximum edge of the MSC is greater than this guy, this new modified edge, what we do is we can remove that maximum edge and replace it with this. If it fulfills two conditions: one, it does not disconnect the MSC; two, it does not form a cycle. Okay. So let's look at the B part. We have an edge that is already in the MST, but when it was modified, it became less than its original edge. This is good news. We do nothing, right? Because it's already in the MST, and when it becomes smaller, it even makes a better MST. So for the last one, we have an E in the MST, but when it became modified, when it got modified, it became greater than its former weight. What do we do? So now we would need to check. After it became modified, has it become the maximum edge in the MST? If the answer is yes, we want to check all the edges in the original graph, and we want to check for particularly edges that are cheaper than this edge, this edge that has this modified weight greater than its former weight. So we want to check for the edges in G that has a lesser cost than this. If we find some, we want to see if when we replace them, or we'll pick any one of them and try to replace it, and try to replace this one with it, right? If in the process of replacing it, it's almost like answering question B. If when we replace it, it doesn't form a cycle, it does not disconnect the graph, then yeah, we can replace it. We have an even better MST, right? But if when we replace it, it disconnects or forms a cycle, then we do nothing still. What's the worst case scenario? The worst case scenario is that it has become the maximum edge in the MST. That's just the worst case scenario. But apart from that, it's still the MST. If we can't find any edge in G that is 1, has a lesser cost than it, 2, does not form a cycle, 3, which also means it doesn't disconnect the graph. So we're going to end here. I hope this was pretty clear. Please do remember to subscribe and comment, like, share, and I'll see you on the next video, which is going to be our very last example on MSTs.